Hello guys, and welcome back to my channel Civil Construction and Tutor, and this is the continuation to the video series ETABS modeling and analysis of a residential building. And previously we concluded our video by modeling the structural elements and assigning diaphragm to the horizontal elements. And in this video I will discuss about how to apply loads on the structural elements and how to calculate those loads. So I'll start with applying the loads to the beam. Firstly, that is the wall load, staircase load. As I said, I will not model staircase in this video. I will directly apply the load of the staircase on the beam on which the staircase is supposed to rest. So for loading, plan view should be sufficient, and for this we'll select one story only, because the wall load may be different in respective floors. And for applying loads on the wall, let me hide the slab. Okay, so select okay, it is unnecessary. Select properties and slab sections. It will select the slab. All the slabs will be selected, and right click, hide selected objects. So the slab has been hidden. Now let me split the window again for better visualizing the architectural drawing. So it will be easier to visualize the loading on the beam. So let us go to the first floor, that is the ground floor. So ground floor beam means this beam, okay, at this level. So the load coming from the first floor will be acting on the beam of ground floor, or we can say ground floor level, top level of the ground floor. So we have a half brick wall at this side, half brick wall, half brick wall, half brick wall, half brick wall. So as we see here, there is half brick wall throughout the circumference. So we have to apply the load considering the half brick wall, and also there is opening in some wall, as you can see here, windows, okay, and some of the wall do not have any openings. So considering the opening, there should be reduction in the weight of the wall acting on the beam. So firstly, let us calculate the weight of the wall acting on the beam. So the specific weight of the masonry brick wall is 19. For beam, we will calculate the uniformly distributed load, that is the load will act along the length of the beam. The thickness is taken as 110 mm considering half brick wall, and the height of the wall is to be taken. So considering the depth, height of the wall, we should reduce the depth of beam, because, so look, I am calculating the load acting on this beam. So this is the height of the floor, 3 meter, minus depth of beam, that means this is the height of the wall. So height of wall will be 3 minus 0.35, that is the depth of the beam. So this is the height of the wall multiplied by thickness of wall, which is 0.11 into 19. Okay, this is the weight of the wall that is acting on the beam, and considering this is the weight of the wall without any opening, and considering the opening, we will reduce the weight by 20 to 30% depending upon the size of opening. So for now I am taking 20% reduction. So 5.53 is the full wall load, and with opening as 20%, that means there should be the reduction of 20%, that means only 80% of the load is to be considered. 4.43, 5.53 and 4.43. Now let us apply this load. So 1 2 3 4 5 6, 1 2 3 for each floor. It also has an opening. It also has an opening, and it should also have an opening because to come to the balcony. Sorry, I forgot that. So it will also have an opening. Now assign frame loads distributed. These are the internal walls. I am just considering the external walls. Okay, so assign and load pattern names. External wall load, it is we are applying the force. Replace existing load, we are applying the uniform load. So and direction of load application gravity, and the load is 4.43 considering the opening. Now you can also do directly from here. 19 into 3 minus 0.35, that is the depth of beam, into thickness of wall 0.11. Okay, and considering 20% opening, only 80% of load will be taken, so 4.43 apply. So the load has been applied, and for remaining other external wall, we will take full wall load, that is 5.53 apply. So you can see it is done. Now let us go to the next floor. Is story 1, z is equal to 6 meter, and the load pattern will be similar. Select all of them. It is done. Now let us provide the half load wall load with opening, apply, and for remaining one we'll apply the full wall load 5.53 apply. Now and go to the next floor. Let us select the wall with openings 6 7 8 9, so it is 0.8 apply, and for remaining wall it is full wall load, that is 5.53 apply. Now go to the topmost floor, that is story 2, z is equal to 12 meter, and for which we will have no any external wall load, because we have applied above this, there is no external wall, so there won't be any load acting on this beam of the external wall. Now we'll apply internal wall load. Let's go to ground floor. Coming back to ground floor, that is at the top floor of ground floor, top level. So on deform shape, and let me select the internal walls 1 2. So you can see here it has opening, it doesn't have opening, so we'll select the walls with opening first. Okay, openings, there is opening in this as well, there is opening in this as well. So this is the partition wall that I will directly apply on this slab. It is resting on this slab, so the load will be distributed on the slab. I'll discuss while applying on the slab. Okay, and this has a full wall load. of, that is a wall with full wall brick. Okay, full brick wall this is. So it will have 0.23 into 19 into 3 meter minus depth of beam, so 11.58. And this also has a wall, and this is a full brick wall, sorry, half brick wall with no opening, so that means 5.53. Apply. So all the internal wall has been loaded with respective loads. So now let us go to the next floor. So 1 2 3 4 5 6 7 8 9. This will have a load of 4.43, that is internal wall with, that is half brick wall with openings, and the remaining one will have load with no openings, and this has a full brick wall, so 11.58. Apply. Now to the next floor. So again, don't get confused, we are applying at this floor, so there won't be any internal wall loads at this section. So we are done with the internal wall load application also. So now let us check its 3D. So are we clear about the loading internal wall? We can also check for 3D loading, sorry, load assign respectively. Go to frame and then select external wall loading, apply. So we have done a mistake over here, there won't be any external wall loading on this beam, okay. So select this, and go to assign frame loads distributed, and these are the external wall loads, so external wall loads, and go to delete, apply. So now it is okay. So this is how you will find out your mistake, and this will be the external wall for this floor, and go to replace existing load and provide. You can see here this has openings, so it is 4.43. Apply. Now it is okay. Let us hide the grid, then it will be much more clear to understand. Are we clear? Okay, external wall load is done, internal wall load is done. Then we have floor finish, roof load, parapet wall. So parapet wall load I will do because it will be acting on the slab, sorry, on the beam. So it will have the parapet wall will be at this section, at this section, at this section, at this section, and also for it. Parapet wall. And now let us calculate the weight of parapet wall. 19 is the unit weight of the masonry. Height of parapet wall considering 1 meter, and thickness of parapet wall as 0.11. Apply. So the parapet wall load has been applied for this section. Similarly it will be here as well. this as well. Apply. Now let us remove for this because there won't be parapet wall for this section. The parapet wall load has been applied. One load is remaining, that is for the staircase. So to apply the staircase load on the beam, we have to consider the number of flight that is resting on that beam. So for now we are not considering the plinth beam and there is neither the landing beam, so we will start from this portion. So here we have a beam and other beam is over here. So the number of stairs that goes up to the mid landing in the ground floor will be 1, and then the number of flight that goes from the mid landing to the first story floor level is also 1, but simultaneously there will be another stair flight that will go to the mid landing of the another floor. So that means the number of stair resting at this beam is 2. Okay, the number of stair flight is 2. Similarly, at this level the number of stairs or the number of flight resting on this mid landing slab is also 2. So that means it will transfer the load of 2 flight towards this beam. So that means the number of stair flight on this beam and on this beam is 2. Similarly, the number of stair flight resting on this beam is 2. This is also 2 because the landing slab transmits the load through the wall at this point. Similarly, at the topmost floor, as there is no further flight going towards the topmost roof, so the number of stair flight resting on this slab will be 1. So the number of stair flight at this particular beam is 1, at this beam 2, 2, 2, 2, and finally for this plinth beam also, if we are considering, then the number of stair flight will be 2, but for this it will be 1. So this is how we will apply load on the beam due to the staircase, and generally the staircase load is taken as 11 kilonewton per meter for single flight and 22 kilonewton per meter for the two number of flights. I will show you how to calculate the load for a particular staircase in next video, so tune for that. Now let's see in the detail. So the staircase will start at this point and the mid landing will be at somewhere at this point, and then again it goes to this point, and again the mid landing will be at this point. So that means the number of flight, either there will be 1 or 2 that will be resting on the beam, and according to that the load of the staircase has to be applied for the beam. So for now we are considering this beam, okay, and from here one staircase flight will go, and at this section both the staircase flight will be resting, okay, and one will be from through the mid landing at this point and the another one will go to the mid landing from this point. So that means 2 flights will be resting on this beam, so we'll apply load and in that pattern. But for the topmost flight, that is at this section, only 1 flight will be resting. Define a new load, add new load, staircase, self weight multiplier 0, add new load, okay. And you don't have to make any changes in other things because it will automatically consider the staircase here, okay. But in the mass source you have to define it, or you have to add that load, staircase add, okay. So this is the staircase section, and this will have 2 flights, so we have to apply the load of both the flights. Generally it is taken as 22 kilonewton per meter for the staircase. I will show you calculation in the another video how we calculate the dead load or the staircase load. For now just take it as 22 kilonewton per meter for both flight, and for a single flight it is taken as 11 kilonewton per meter. So let us select this, okay. After applying load you will be clear about how the staircase is going. assign frame loads distributed staircase, and it is taken as 22 kilonewton per meter. Okay, and finally in this, okay, this also has 22 kilonewton per meter, and the final one at the top most will have only 11 kilonewton per meter. So if you see here, the staircase goes like this, and two flights will be resting over here, and then again mid landing will be at here. Okay, and both the staircase will be resting on this beam, and then it will go, and both the staircase will, or the both flights will be resting over here, and again to the mid landing, and in the mid landing it will rest on this beam, and finally the only one step will go at this point. So it will have a single flight loading. I hope you are clear about this. So finally the loading on beam is completed. Now we will apply load on the slab. You can also cross check by going to display load assign, and for external wall loads, so we have applied the external wall load. Similarly, internal wall load, so you can see we have done a mistake again. We are not going to apply at this second because we have already done this for external wall load. So this is how you will rectify your mistakes. Cross check it, apply, because we have already applied the load for that particular portion. And then staircase load, okay, and finally the parapet wall load. So if the roof is accessible, then we'll provide parapet wall in this as well. Let us take the parapet wall in this section also, considering this section will have a staircase, that is the spiral staircase. Assign frame loads, parapet wall load, it is 2.09, apply. So finally the load on the beam has been completed. Now restore, or we can say show all objects. Then we have beam as well, and slab is now visible to us. Now we'll apply load on the slab. Okay, on deformed shape, select select and go to properties, slab section, select all these slabs, and I will apply the floor finishing, that is same throughout the floor. Assign cell load uniform, and we have floor finish, and generally it is taken as 1 kilonewton per meter square. Apply. So it is done. Similarly, select the roof slab. So this is the roof slab, and these are also the roof slab. And this has to be provided with roof load, that is roof live load, and it is taken as 1.5 kilonewton per meter square for roof. Okay, and for the remaining it is taken as 2 kilonewton per meter square. You can do by going to the plan view or elevation view. Plan view, we cannot do it the elevation view, sorry. So I'll take this as the live, and provide 2 kilonewton per meter square where the accessible or where people will live, that is to be provided with the 2 kilonewton per meter square. And okay, it is done. For balcony projection without with no support, now we have a support of the column, so we are giving 2, but for the cantilever slab projection we have to provide 3 kilonewton meter square, so that is for this. These are the cantilever slab projection, so we will provide 3 kilonewton per meter square at this section. Got my point? So we are done with staircase, parapet wall, roof load, floor finish, live load. Okay, close. You may get confused with the loading of water tank. Okay, I got one point. Water tank. If there is a water tank at the topmost level, then how the load is distributed? Generally, the water tank load is distributed over the slab. So let us consider that we have a water tank at this portion or at this slab, and the volume of water tank is 1000 liters. 1000 liters means 1 meter cube. So we have to divide that load or the load of the water tank at this slab or for this slab, and it is divided throughout the area. So we can find out the area of that slab. So let me show the grid and then we will get the dimension as well. So the area of this slab is 3.35 into 3.3 meter, and that area is responsible for distributing the load coming from the water tank. Define a new load pattern, that is water tank. Water tank dead and it will be 0. Add new load. Okay, and again go to load cases, it will be automatically added, and for mass source you have to add that load. You can consider that load as a live load as well, but for now I'm just taking that as a dead load. Okay, now we have to assign load. Cell load uniform. Let us go to water tank. Now what will be the value of the load? So 9.8 is the specific weight of water into volume of water tank 1 meter cube, and it should be distributed in that area, so divided by 3.35 into 3.3. so this is the load of the water tank acting on the slab. Apply. Similarly, we had partition wall at this section also. Okay, you can see we have wall at this particular section, but it has openings, so it can be neglected. Okay, I will take for this. So the length was 1.1 meter and it is distributed in this slab. So the area of this slab will be 3.29 meter into 1.1. So let us select all the stories. We'll do by one. Okay, so this assign cell loads uniform internal wall load, and it will be distributed in this. So the specific weight is 19 and it will be done by considering the volume of the wall. So 0.11 is the thickness and the length of the wall is 1.1 meter, height of the wall is 3. This time it is resting on the slab, so we have to reduce the depth of slab only 0.125. Specific weight into width of the wall into length of the wall into height of the wall divided by area of that slab, 3.29 into 3.3 meter. So this is the load that will be acting on this slab. Apply. For this also same, and above this there won't be, okay, up to here it will be. I'm neglecting this wall, okay, it has opening, so I'm not taking this. You can take, so 0.608. so this is also done. So finally the loading of the structural elements has been done, completed. So after this we'll go into the analysis phase, so that will be done in the next video. Thank you.